Hi everyone, welcome to Vectors and Relativity. In this video, we will talk about how to draw and add vectors graphically.
Okay, let's look at this first example. Draw the following vectors with a ruler and protractor. So let's look at vector A, 5 meters at 30 degrees. The first thing that we want to do is we want to create a legend. So we're going to say 1 centimeter equals 1 meter. Next thing that we want to do, we want to create a small cross section like this. And it just kind of helps us kind of show where things are. So 30 degrees, this is going to be 0 degrees, and then counterclockwise is going to be how the degrees go. So 30 degrees somewhere in this first quadrant right here. So what I'm going to do is I'm going to get my protractor. Not the nicest protractor, but I'm going to get my protractor. What I'm going to do is I'm going to mark where 30 degrees is. So from here to right here is 30 degrees. So I'm going to get my ruler, and I want 5 meters, but my legend says 1 centimeter is 5 meters. So I'm going to go 5 centimeters in that direction. So this is my vector. At the end of the vector, I'm going to make an arrow that's important to distinguish where it is. And this is vector A. Okay. Vector B says 8 meters at 170 degrees. Okay, so this is going to be same thing. I'm going to make the same amount, even though it's going to be bigger. 1 centimeter equals 1 meter. So I'm going to make that legend again for this vector. And I'm going to make my cross section. I'm going to go over here, yeah. I might probably cross into this, but it's okay for this one. And this time I have to go 8 centimeters. Put the 8, oh whoops, sorry, I have to find where 170 is. I put the cross section right there, and 170 is going to be like almost completely the other direction. So 170 is going to be right here. I'm just going to mark it. Sorry, I had to cross it. So this one is B, like that, vector B. Vector C says 20 centimeters at south. So we're just going south. This time I'm going to make it a little bit bigger because I don't want to draw 20 centimeters. That's almost the whole page. So I'm going to make my legend 10 meters equals 1 centimeter. And this time I'm going to draw my little cross section like this. And all I have to go is 2 centimeters because 2 centimeters equals 20 meters. So I'm going to go from here to here, and I'm just going to go 2 directly downwards. That's 2 centimeters, which equals 20 centimeters. 20 meters. This is my vector C. Okay, so this is where it gets a little confusing. 4 meters at 15 degrees north of west. Okay, so how we're going to do this is first we're going to make our little legend. Now let me do D over here. I'm going to say again 1 centimeter is equal to 1 meter. I'm going to make my little cross section here. And then, so this says 15 degrees north of west. What we want to do is we want to look at the second word, so west. And then we want to go 15 degrees north of west. So this is west, and we want to go 15 degrees north. So we're going to go up this way, 15 degrees. And that's what I'm going to do with my ruler. I'm going to put it, right there. And then I'm going to go up 15 degrees. I'm going to go up 15 degrees, which is about right here. And then this is my arrow, and then this is D. Vector D. Alright, vector E says 7 meters at 40 degrees west of south. Okay, 40 degrees west of south. Okay, so again, I'm going to make my little legend here. 1 centimeter equals 1 meter. And then I'm going to draw my little cross section here. And again, let's think about this. So it says 7 meters at 40 degrees west of south. So this is south. We want to again look at the second word, south. And we want to go west of south 40 degrees. So we want to go west, meaning that way 40 degrees. So I'm going to get my protractor, and from the south point, I'm going 40 degrees. So 10, 20, 30, 40, right there. There's going to be a little bit of error in these kind of things. All right, the last one, F, says 5 meters at negative 120 degrees. So what we're going to do again, we're going to make it right here. 1 centimeter is equal to 1 meter. I'm going to do my little cross section here. And then, so this is 0 degrees. East is always 0 degrees, and we usually go 120 degrees. We usually go this way. However, if it's negative, that means we're going to start to go the other direction. So this would be 90, and then 100, 110, 120. So what I'm going to do, I'm just going to flip this upside down here. And this is going to be 90 degrees going directly south, but then 100, another 100, 110, 120. So I'm going to make a little dot there for my reference. And then I'm going to... Okay, and this is vector F. And that's how you draw these vectors. Okay, you want to have a legend first, then you want to make this cross section, then you want to draw where the reference is of where to go, and then you want to make the end of it, draw a little arrow. Alright, so now let's try interpreting these. So, for this next question, express the right direction for each vector. So we see this vector here, and we want to just express the right direction. So maybe something that will help us out is if we put this cross. So if we put this cross here, like this, and then we have this 50 degrees. How we could express this is always starting at 0 degrees here. So if this is going up like this, 50 degrees, we could just call this at 50 degrees. Another way we could say, let's talk about this, is at 50 degrees north of east. Because this side is east and we're going north 50 degrees from east. Another thing that you could say is if you wanted to do this angle here, let's say you have this angle here, we could have said at 40 degrees, but from 40 degrees we're going east of north. East of north. Because this is north, again we're looking at the second one, and we're going east of north 40 degrees. So those are all the ones you could do for the A, vector A there. Let's look at vector B with this one here. Again, let's make that little cross section. We see this is 20 degrees right here. And there's a few things we could say. We can say if this is 0 degrees here, all the way from here to here gives us a certain angle. And we know that whole thing was 180, so that would be at 160 degrees. Maybe I'll just do it with different colors actually. Or if we wanted to do this one over here, we have to think of what this is and what which direction. So this is west going north. So we could say at 20 degrees north of west. You could think of north from west. So this is west. We're going north from west 20 degrees. Another thing that we could be looking at right here is just from right there. And if that's 20, we know this is going to be 70 degrees. So we can say at 7 degrees west of north. This is north. We're going west of north 7 degrees. Okay. So a lot of times students get confused with that. So make sure you understand. Let's look again at this one here. Drawing that cross section. If this is 0 degrees, we could think of what this is all the way over here. And that's going to be 180 plus 30. So that's going to be at 210 degrees. We could call it that. Or if we just look at this angle here, that's 30 degrees. So at 30 degrees, and we call that south of west. Or if we're looking at this angle right here, that's 60 degrees. We could call that at 60 degrees west of south. Okay. All right, let's look at D. So there's a few things we could do with this one. instead of always going counterclockwise, if we went the other direction like this, then we could call that a negative. So we could call this at negative 20 degrees, and that would be fine. Or what we could do is, if we just see this going down that way, we could say at 20 degrees south of east. So this is east, we're going south of east 20 degrees. South of east. Okay, and then I guess we could also do, for this one, let's go all the way, we could go all the way around like this. And if this is like that, then this is going to be at 340 degrees. Okay, all those options would be fine. Okay, so for this one, let's again draw the cross section. Then, if we went like this, we could say this is going to be at, what is this? At 160 degrees. Or we could just use this part right here, and we could say at 70 degrees west of north. Or we could use this part right here, which we know is 20 degrees, and we could say at 20 degrees north of west. All right, let's look at the last one here. Do a little cross section. Again, if we start at 0, which is honestly like my favorite one, we go from here to here. So we could say this is at 15 degrees. Or we could say at this 15 degrees north of east. Or we could say, if we use this 75 degrees, at 75 degrees east of north. Okay? So anyway, I just showed different options of how to label the direction, but you only need to use one of them for each of these. So whichever one you feel most comfortable with, you should be using that, okay? So you only need to be using one of these for each of these answers. Okay, so let's look at the next example. Graphically add the following vectors. A is equal to 10 meters north, B is equal to 7 meters at 30 degrees, and C is equal to 4 meters at 90 degrees south of east. Okay. So the first thing that we want to do when we're doing these problems is we want to create a little legend. So I'm going to say 1 centimeter is equal to 1 meter. Then what I'm going to do is I'm going to have a little cross section here. And the first thing I'm going to do is 10 meters north. So I'm just going to go straight up 10 meters. And you want to be as exact as possible, but if it's not perfect, it's okay. So I'm going 10 meters north. And I'm just going to label this vector A. And then afterwards, what I like to do is I like to create another cross section where it ended up. So you know you're always going to start, whenever you're adding, you're going to start where you ended up with the first one. So A is there. B is 7 meters at 30 degrees. So now I'm going to get my protractor. And 30 degrees. Remember 30 degrees? This is 0 and we're going up 30 degrees. So 30 degrees, I'm just going to make a little reference point right there. And I'm going to go 7 meters up that way. Ooh, this is getting off the page. Maybe I should change the legend a little bit, but I think it's fine. Okay, this is 7 meters. Call that vector B. All right, and now vector C, 4 meters at 90 degrees south of east. Okay, so let me make my cross reference again. So this is east over here. I'm going 90 degrees south. So that's pretty much just going directly downwards like this. And we're going to go 4 meters downwards. So I'm going 4 centimeters directly down. Like that. And then this is where we end up. So when we added them all together, this is where we end up over here. How we want to now find what it all adds up to is, there's a few ways. You could use a different marker, or you could start over, but you want to connect where you began. So this is where you began and where you ended up. And you want to draw that on here and make it noticeable somehow by either making a dotted line or using a different color like I am, but make it noticeable somehow. So I'm gonna make it dotted and use a different color like this. And this is what we call our resultant vector. So this is what we call our resultant vector. I'm just going to do R, vector R. And I want to measure this. So what I measure when I make my resultant vector is this is going to be 11.4. So this is 11.4 centimeters. But I put it back into my legend, and I find that this is going to be, my resultant vector is going to be equal to 11.4 meters at, and then let me see what I can do with this. Now I'm going to use my calculator to find the direction of this. And what I see is this is going to be around 55 degrees. So I find that this spot right here is 55 degrees. So I could call this at 55 degrees, or I could say at 55 degrees north of east. Or if I measured this angle over here, this is going to be 35 degrees, so I could call it at 35 degrees east of north. Any of those answers would be correct. Any of these directions would be correct. And even if you didn't get exact 11.4, that's totally fine. I think actually the exact answer is 11.27 meters at 57.5 degrees. So when you're doing it graphically like this, you won't get the exact answer much of the time. But I'll be showing how to do it mathematically later on. All right. Okay, so for this next problem, this is a bit more, this is different because what we have these negative vectors now. But don't worry, when we're doing negative vectors, it's pretty much the same thing. All we're doing now is flipping the vector. So if it says 10 meters north, now we're just going 180 degrees the other direction. So we can say this is going to be 10 meters south, okay? So, again, first thing you want to do is you want to create a legend. I'm going to say, again, 1 centimeter is equal to 1 meter. And then we want to create a little cross section. So just do it like this. And instead of going 10 meters north, since this is negative, I'm going 180 degrees the other direction, which is 10 meters south. Or in this case, I'm going to be drawing out 10 centimeters. Okay. I'm going to label this vector negative A. And then it says, now I'm going to make, again, that little cross section again. And then it says 7 meters at 30 degrees. This is not negative, this is positive. So we're just going 7 meters at 30 degrees. I'm going to label where 30 degrees is. This is the reference point right there. And now I'm going to go 7 centimeters in that direction. Let's see, just like this. Good. 7 centimeters, and this is vector B. And now this has 4 meters at 90 degrees south of east. So when we're doing now, since this is negative, what I want you to do is I want you to cross out both of these and do the opposite. So if it says south, cross it out and write north, and if it says east, cross it out and put west. So now you can think of it as 4 meters at 9 degrees north of west. So again, let's look at this. West is over here. We're going to go north 90 degrees. So it's going to be going straight up 90 degrees. So I'm going to go 4 meters straight up. Okay. And this is negative C. Now we drew everything. So now what we're going to do is we're going to draw our resultant vector. This is where we began, and this is where we ended, okay? And we're drawing from where we began to where we ended. A little hard to see. Oh, whoops. And this is my resultant vector. I wanted to make it dotted, but I kind of forgot to do that. Let me see. This is going to be about 6.5. So it's about 6.5 centimeters, which we put into our legend, which is 6.5 meters. So I can say my resultant vector is equal to 6.5 meters at, now we get our protractor, and let's do some angles here. I'm gonna go like that, and this looks like it's about 23 degrees. So I can say, oh, this angle is 23 degrees. So I'm gonna say at negative 23 degrees. Another way we could say is at 23 degrees south of east. Or if we found this angle right here, from here to here, that would be 67 degrees. We could say at 67 degrees east of south. Any of those answers would be correct. Okay, so that's how you do negatives. We'll probably do a little bit more examples of that later on. A few more examples of that later on. Let's see, example number 4. You're looking for a treasure chest. A friend tells you to walk 5 miles north, then 2 miles west, and lastly 4 miles north of west at 30 degrees. Explain graphically how to get to the treasure from where you started. Okay, so we're going to just draw this out pretty much just in an adding vectors problem. So again, we want to make a legend. So I'm going to do 1 mile is equal to 1 centimeter this time. And let's see, I'm going to start over here. And so I'm going to go first 5 miles north. So I'm going to just go 5 miles directly north. Like this. And I'm just going to label it vector A. The first one, vector A. Oops. Alright, and then after that it says then 2 miles west. So I'm going to make my cross section again. This is where we always start the next one. And I'm just going to go 2 miles to the left, west. Or 2 centimeters, which is equal to 2 miles. I'll call that B. And it says, lastly, 4 miles north of west at 30 degrees. Alright, so north of west. We again want to look at the second word, which is west, and we want to go north 30 degrees. We want to go north 30 degrees. So get my protractor. 30 degrees is right here from west. And now I'm going to go 4 miles, which is 4 centimeters in that direction. Just like that. Oops. So we found our ending point. It's right here. See? And now we want to make our resultant vector. So this is where we began. And this is where we ended. And we want to draw from where we began to where we ended. Okay. And then I want to draw the arrow from where to where we ended right there. So this is our resultant vector. And make it noticeable somewhat. Maybe if you want to. But the resultant vector should look different than all the other vectors so that you know which one is which. Now that I have my resultant vector, I measured it. This one was equal to 9 centimeters, which is equal to 9 miles. Now I'll use my protractor for the direction of it. And I see that this is going to be equal to 50 degrees right here. This is 50 degrees. So I could call this at 50 degrees north of west. North of west. Another way I think of it is north from west. Another way we could see this is we could see this angle here, which is 40 degrees. We could call this at 40 degrees west of north. So west from north, northwest from north. Another way is, and what I like to do is starting from the 0 degree angle, go all the way this way, and we call that at 130 degrees. Okay, and any of those answers would be correct. All right, let's look at the next problem. So it says, find what A plus B equals graphically. So we know A is equal to 4.5 at 30 degrees north of east. And B is equal to 6 at negative 60 degrees. So How we're going to add this up is we want to essentially put this B over here and then see what everything is from the beginning to the end. So we don't really have to make a legend because there's no units here. But what we want to do is we want to start drawing this out. So let me okay, actually I'm going to start over here. Okay, so 4.5 at 30 degrees. So let me first make the reference point of 30 degrees. See, it's right there. I'm going to go 4.5 centimeters in that direction. 4.5, this is vector A. And now, okay, so now we want to make our cross reference, this. And now we're starting B. B is at negative 60 degrees. So I'm going to flip this the other way. So we're starting from where A ended. And 60 degrees downwards is going to be this way right here. So we're going to go 6 centimeters down that way. Whoops. Okay. And this is B. And now our resultant vector is from where we started to where we ended up. This is where we started and that's where we ended up. So I'm going to go from here to here. Okay. And for my resultant vector, what I get is it's going to be around 7.7, and there's no units because it's just 7.7. And then at, oops, it's a little bit hard to see. So let me get my protractor here. And we see that this is going to be at around 20 degrees right here, which we could call at negative 20 degrees, or at 20 degrees south of east. All right. Thank you guys.